Welcome to solverfy.
.84. So we have 2 point sources here emitting light in phase. And we've got a screen over here, and we're looking at some generic point P. The separations between the points and then the right point and the screen are given. And we have a number of things we'd like to learn about this. So the first one is what point on the screen has the minimum phase difference. So if we think back to looking at this sort of thing in general with a screen like this, we know that the minimum phase difference is going to be here where the path lengths are equal. But here the path lengths are always unequal until you get to infinitely far along the screen, at which point they're both, they approach being vertical in that limit. And then their path lengths are both infinite. And so the minimum phase difference occurs at infinity. And multiples of wavelengths, since there's no path length difference, then the phase difference is 0. Either in radians or in wavelengths. So now we want to know for the maximum, or max, the maximum phase difference. So when we're at y equals 0, the path length difference is d, and you can determine, if you'd like to work it out explicitly, that this is the maximum path length difference. But if you think about it, just the separation between them has to be the maximum path length, and so on the horizontal line joining them is where that will occur, which is at y equals 0 on the screen. Now we said that these are 6 wavelengths apart, and so that's going to be their phase difference on the x-axis. Now if we look at the point that's D, the separation above the origin, we actually have to do a calculation. So, if this is a distance d, then from the Pythagorean theorem, we've got d squared plus d squared that's for this one, little d plus big D squared plus another little d squared minus little d squared minus big D squared, plus divided by lambda. These are all in terms of lambdas, and so all the lambdas will cancel. And so this is 5.8 wavelengths. So we know that at every full wavelength, we have constructive interference, and at every half integer wavelength, we have destructive interference. So since this is between 5.5 and 6, where we have a minimum and then a maximum, this has intermediate brightness.